Hello, my name is Casey Shibler and I'm doing a reassessment video on the Circuits 2 standard. I've chosen the following problem. It says the conductivity of tungsten at room temperature is 1.8 times 10 to the 7th. That thing is significantly smaller than that of copper. At the very high temperature of a glowing light bulb filament, nearly 3000 kelvins, the conductivity of tungsten is 18 times smaller than it is at room temperature. The tungsten filament of a thick filament bulb has a radius of about 0.015 millimeters. Calculate the electric field required to drive a 0.2 amp of current through the glowing bulb and show that it is very large compared to the field of the connecting copper wires. So, what are we looking for, really? We're trying to calculate the electric field required to drive a certain amp value or current through a glowing bulb. I know that I is equal to delta V over R. I also know that E is equal to delta V over L, and V equals I are rearranged. I looked up in the book and saw that, well, first of all, since delta V is equal to IR, we can plug that in. We have E equals IR over L. But I looked up in the book and I saw that R was equal to L over the conductivity constant they gave me times the area. So they've given me the radius and the area, so therefore I can actually use that and plug it into R, and I get E is equal to I times R, which is L over the conductivity constant pi r squared over L. And this allows my L's to cancel because I don't have a value for L, so having that gone is a good thing. I then plug in my values, which is 0.2 amps over 1.8 times 10 to the 7th times pi r squared, which they gave me R in millimeters, so I had to convert that to meters. I checked my units because I get 15.7 volts per meter. When checking my units, it all cancels out and that gives me volts per meter, so that's right. It then asks to show that the electric field of the filament is larger than the field of the copper connecting wires. We know I and we know R squared, and it says here that, oops, let's see, wrong page first of all. It says here that the conductivity of tungsten is significantly smaller than that of copper, and I even looked it up on another source to say that tungsten is much less conductive than copper. So if that were the case, then this variable would increase, which means that if the denominator increases going into the same numerator value or value in the numerator, the electric field is going to be smaller. So therefore I can actually say that the electric field of tungsten is a lot larger than the electric field of the wire. How much, I'm not sure. I was not given a value for this, and yeah. So this is my problem.